Alright guys, here is question 9 based on Euclidean geometry. So now let's have a look at this one. It says that here they've given us a theorem. They want us to prove this theorem. I think proving this theorem was worth 6 marks in this question. So they said in the diagram below, O is the center. Alright, we see the center here. And then they say that it is passing through P, Q, R, and then the chord P, Q, and R are drawn with O and Q and R joining together, as we can see that. So use the diagram provided in the chart. See, this is on your answer sheet to prove the theorem that states that angle suspended by an arc at the center of the circle is double the size. All right. So basically they want us to prove that O is going to be, they want to prove that this angle here is going to be twice that one there, right? So, you know, guys, with this theorem, I think is there on the textbooks as well. To prove this theorem is quite straightforward. First thing that you need to do, you need to construct a line here to divide this into two triangles. Right, there you go. Then we can mark this as P1. Then we can mark this as P2, which is an angle. We can mark this as O1. Then we can mark this as O2. Basically, what you have done now, you have divided in this shape into two triangles. So what you can do, you can work around it. How many triangles that we have here? You can come here and say in triangle, which one should we start with? Let's start with P O Q. All right, so in triangle P O Q, which is this one here, can you see, guys, here? I'm gonna try to use different colors here so that you guys can see what I'm talking about. This angle here, it's an exterior angle to this triangle. So what I will do now, I'm going to draw this triangle here. Oh, I almost said draw this triangle here. So, right, there you go. I'm gonna try to make it look like the one that you see there, so that to avoid any confusion, there goes the dotted line there. You go. Is it like this? No. Oh, what am I doing? Okay, it's not like that, but it's like this. It's like that. There you go. So what you have here, you have got O there. You have got O1, which is this angle here. And then what you got there, the O is at the center. We have got P1, that is right there. Right. So guys, if you have a look at this, if this is the center, therefore these lines should be equal, which makes this triangle an isosceles, because this is what? Radius. All right. So that now when you have that now, all right, so this angle here, this angle here is the exterior angle of a triangle, right? So you would know with the exterior angle of a triangle, this exterior angle is equal to the sum of the internal opposite angles. So therefore it means O1 is equal to Q plus P. All right. However, because now you have got this one, the reason here you're going to say exterior angle of triangle, right? However, because equal size suspend equal angles, therefore it means now you can come here and say the Q is equal to P. Reason being opposite. Reason being you can say angles of opposite sides, or opposite what? Equal sides. Opposite equal sides. Right, you can say that. So therefore it means now O would have to be, O1 would have to be P1 okay, plus another P1, where if I substitute there, okay, so meaning therefore is going to be equal to twice P1. Okay, great stuff. So now let's go again to another triangle. Let's go to another triangle. You can come here and say, okay, in triangle, the other triangle there would have to be angle RO, angle ROP, angle ROP. Okay, angle ROP, not Q, ROP. There you go. So now therefore, if you come here, you can say now, let me draw this triangle here for the sake of understanding as well. So this triangle here, the dotted line, it goes like that. And then what you're gonna have, you're gonna have this line here. There you go. And then here it's O. You're gonna have what? O2 here, P2 there. And then you're gonna have R here there. These sides are equal, the same as before. So therefore O2 is going to be equal to angle that, which is the exterior angle of a triangle, reason being exterior angle of triangle, same as before. And then R will also have to be equal to P2, reason being angles opposite equal sides. Okay, there you go. So therefore it means O2 would have to be equals to P2 plus P2 as well, so which makes O2 be equal to twice P2. Okay, so therefore now you can come here at the end and say, okay, the total of O1 plus O2 is equal to 2 P1 plus twice P2. Therefore O1 plus O1 will give us O, and therefore here what are you going to have? You're going to have 2 times P1 plus P2, which just gives us twice P now. So that's O is equal to that. So now you have successfully proven that the angle at the center is equal to twice angle at the circumference. All right, that's how you would prove this theorem. I don't know if it's theorem 7 or theorem 6, but that's how you would prove it like this, and then you'll get full marks. I hope you guys fully understand it. I'll try to break it down detail to detail as well. All right, so let's move on to 9.2. All right, 9.2, they said in the diagram below, DF is the diameter. DF is the diameter. All right, we see DF there is the diameter, and then O is the center of the circle. So if this is the center, guys, I always tell my learners, if they speak of the center, you must somewhere clear look for the radius. So here it's a radius. Therefore here it's also a radius, which makes E3 and then F1 to be equal as well. All right, and then we can also see DO, it's also a radius as well. All right, and then they said chord EG intersects DF at H. We can see that there it is there, and then such that DF is perpendicular to EG. All right, we can see that. So therefore this means that from theorem number 1, if a chord is drawn to bisect, it will bisect the chord into equal sides. All right, and therefore there's the chord EF and GF is drawn, and then we are given this angle here at G as 55. And then 9.2.1 says determine the give with reasons the size of the angle D. Okay, let's go angle D. If you ever look at this one, guys, angle D, it's equal to that. If you have that, angle D, it's equals to G, it's equal to G, and then our reason will have to be what? Angles on the same segment. Excuse me. angles on the same segment. Yes, it is, guys, because you remember this theorem here. If you have a chord here, then you have got angles there on top from the same chord. These angles there will be equal as well. So therefore D would have to be equal to 55. Okay, B, they're asking us to find O2. O2 is the angle at the center. So therefore it means you must look for something that is equal to angle at the center is twice angle at the circumference. So if you have a look at here, if you have a look at when we speak of this, we speak of these angles like that. When you have something like this, no, it's not like that, guys. You will remember this theorem like this. If you have a theorem like that one, angle at the center, which is this one, is twice angle at the circumference. If you do remember this theorem here, it means, so now if we have got G here, which is 55, G, it's equals to the angle at the center is twice angle at the circumference, which is G. Okay, so therefore you have that. So our reason would be angle at center, it's equal to its angle at center is what? Twice angle at the circumference. It's equal to twice angle at the circumference. Oh, don't mind, guys, it's my youngest daughter here making noise. But anyway, let's continue. You want to do maths? So therefore it's equals to twice G. So therefore O2 will have to be equals to twice G, which is 55. When you times that by 2 is going to be 110. All right, so now C, they're asking us to find E2. Okay, so let's come here and have a look. E2, we already have this one here, it's 110. So E2, if you see here, if these two lines are perpendicular to each other, this is 90 degrees. So therefore angles on a straight line, you can come here and state it and say if H3 is equal to 90 degrees, so angles on a straight line, it means that now H3 plus H2 must give us 180. What can you say? You can say angles on a straight line. Okay, so now therefore ultimately it means H2 is going to be 180 minus 90 degrees, which is going to give us 90 again. Okay, all right, so now you have got a 90 there. So now if you have a look at this triangle here, triangle E with E2 there, and then H and then O, it has got something like this. I'm gonna draw it here. Apologies for that, guys. My daughter is disturbing me. She is only 1 year old, but yeah. Okay, so you have got this angle here at O, which is 110, and then you have got a E2 there, which is the one asking us to find, and then you have got H2 there, which is 90 degrees. So now if you have got that, this is an exterior angle of a triangle. So we know that exterior angle of a triangle, which is O2, is equal to sum of the internal opposite. So it's going to be equals to H1 plus E2. Okay, so here you can say what? Exterior angle of triangle. Okay, so we already know what is O2 is 110. It's equals to H1, it's 90 degrees, and then for E2 is going to be how much? Therefore we can come here and say okay, E2 is equals to 110 minus 90 degrees, which is equals to 20. It's equals to 20 degrees. equals to 20 degrees. Okay, so at least we managed to find E2 is equals to 20 degrees. All right. Okay, so now let's go to D. Question D. It says here we need to find, I'm gonna use a different color for this one. It says here that we need to find E3. So E3 is here. This is what we're looking at now. So we already have O. However, if you ever look at this triangle, guys, I'm gonna draw it here for the sake of understanding. These two sides are equal, and then we have got O there. We have got 1, 1, 0. Then we have got F here. Then we've got E here. We've got E here. And therefore, when those two sides are equal, so therefore it means these two angles are also equal as well. We got this from an isosceles triangle. Don't forget the rules of triangles, guys. Very, very important in this question here as well. So what we can do now, we can come here and say, okay, therefore O, angle O plus angle F plus angle E, which is what, E3, what we're looking for, and then also F1. Okay, F1 and E3, they're equal to 180. Sum of angles in a triangle, we already have this one, which is equals to 110. Therefore, but we know that from isosceles, when two sides are equal, therefore these two sides will also be equal. Just bear with me, guys, with the noise. I apologize for that. Is equal to E1. I'm doing the best I could to make sure that you guys have these videos before you write exams, so it's fine. So now if you add these two together, they are equal. So therefore it means here is just gonna be E3 plus another E3 again, because they are equal to each other. Okay, not the whole of F, but F1 and also F and also E3. They are all equal to 180. Therefore 110 plus twice as much as E3 is equals to 180. So you take this one that side, 180 minus 110 minus 110, E3 is going to be equal to equals to 70. Put this on our calculator, is going to be equals to 70 degrees divided by 2 divided by 2. E3 is equal to 35 degrees, and that's how you would have to find this one as well. E3 is equals to 25 degrees. Apologies for the noise there, guys, but I hope you guys can hear me. It's fine. All right, let's move on to the last question on this paper, 9.2.2. Right, 9.2.2. It says here the determine OH, which is this one here. Said we must determine OH, which is that one there. We already know that this is equals to 90. We already know E2. Do we know E2? Do we really need it? Okay, we really don't really need it. It's fine. And then they said the diameter of the circle is 10 units. Which one is the diameter? The diameter is this one from here to there. Okay. So if the diameter is 10 units, it means the radius is what? It's 5. And we know that this is the radius. This also is the radius. So the radius is 5. Radius is also equals to 5 there as well. And then they said GE is 9.4. GE is this whole length here of this line. GE is 9.4. But we know that from the first rule that if you were to draw, if you've got a circle, then you've got a chord here, you draw a line from the center, it bisects this into equal two halves. Therefore it means it means that what does this mean? This means that it means that you need to divide 9.2 by 2. So therefore it means EH in this case is going to be 9 all over 2, which gives us 4.7. So it means here it's the whole of it is 9.2, but it means here it's 4.7, and then also EH is also 4.7. Therefore, so if I have got these two and then I've got a right angle triangle, it means now I can easily use Pythagoras theorem. What is let me draw our triangle here. There it is. Our radius is this one, is equals to 5. Here we've got 4.7. Here we've got E2. Therefore here we have got O1. Then here we have got H2. Okay, and that's how it looks like. They want us to find OH. Therefore it means EO squared, it's equals to OH squared plus EH squared. Therefore, this is Pythagoras theorem, guys, where you remember this SR is equals to x squared plus y squared. Okay, in case you are lost. All right, so therefore E is going to be 5 squared is equal to OH, that's what we're looking for, plus EH, which is also 4.7. Guys, there's many ways to kill a cat here. You could have used sine rule, you could have used other stuff as well. We have got the angle here. This angle was equals to 20. You could have used ratios as well. There's a lot of things that you could have done besides using Pythagoras theorem in this question. And therefore, when we come here, we can come here and say, therefore, OH is equals to 25 squared minus 4.7 all squared, then square root. I already taken the square root there, guys. OH is therefore equal to is going to be equal to 1.71 units. All right, so what am I saying when I said there's many ways to kill a cat? Okay, I'm going to use a different color for this one. You could have done this, guys. You could have, because you've got a triangle, you know that this is 20 degrees here. Let's say you didn't find this part here. You didn't find EH. Even if they gave you there, you didn't find it, but you're looking for OH. So what you can do, you can use opposite. Okay, so which ratio has opposite, which is OH, over hypotenuse? Opposite over hypotenuse, it's sine and angle. Angle, which is what angle? 20. So therefore, you can just cross multiply here and find OH, which this one was a simpler way, provided you manage to find that the angle was 20. So therefore, you will find that even in this case, you are going to find that it will be just simple and straightforward in this case, where you said opposite, yes, opposite over hypotenuse. Then you are going to find that it is going to be equal to 1.71. All right, great stuff, guys. So with that said, did I do this correctly? Let me see. Oh, yes. All right, so yeah, and that's how you would deal with a question like this one, guys. Let me see you on the next upload, where we'll be doing question 10. I am Gaston Mapala. See you then. Give this video a like.